Hey guys, how's it going? So in the last tutorial, I showed you guys how to download and install BURAI, which is a GUI for Quantum Espresso, which is an open source DFT simulations package. So in this tutorial, we'll be learning a few more things. So particularly, we will be learning how to model various kinds of systems. So just go ahead and, you know, in case you didn't watch the last tutorial, then just go ahead and go to the bin folder of your BURI package and just double click on the application file, that is a Java file. So once you open it, you can just head over to my projects and then just click on examples. So there are plenty of examples over here that come preloaded with the software. So just go ahead and click on save and open any system that you want. In my case, let's say we'll be using an FE system, that is iron, and it has a BCC crystal structure, that is body centered cubic. So when you open it, then you will see that currently you have the geometry tab selected. So here you can specify all the geometrical specifications for your system. So in these there are three tabs here. That is a cell tab where you specify the lattice type. So the good thing is you don't need to worry about, in Quantum Espresso you have all these codes, that is eyebrow. So they go from something like 1 to 12 or 14 or something like that. So you don't need to worry about all these codes, although you can always refer to the Quantum Espresso input file if you forget them. However, this software manages that all by itself. So if you change the lattice type from here, then you can just go ahead and reload this file and get the particular, Quantum Espresso eyebrow code. Eyebrow, I believe, stands for BURAI lattice or something like that. All right, so just change it back to cubic, and then you can even specify the all these lattice parameters. So if you have a cubic lattice, then you only need to specify a single lattice parameter, that is a right here. So you can specify that in all sorts of ways. And then if you have some other kinds of lattice, then you can even specify other things. So, and another thing is, if if you are providing a lattice type from here, then you provide all the lattice parameters like this. However, if you are choosing to go with a free lattice, then you can even specify the lattice vectors using a matrix kind of thing. So when you reload your input file, and if you're wondering how to get this input file, I'll just show you. Just click on this tab right here and go to input file. So in that case, you will have all these cell parameters here, and currently we are in extron mode. You can go to a lattice or bore bore units. So you can just reload your file and you will see the corresponding changes reflecting in the input file. So that was the cell tab. Then you have the elements tab. So here what you can do is you can choose the pseudo potential for your element. So just go ahead and click here, and then you will have all these various pseudo potentials here. And the best part is that it even shows you the the suggested cutoff wave function energy and the cutoff for charge density, etc. So you just click on this icon right here and you can see the all the text in the input file. So usually input files come with those suggestions. Somewhere down here there will be a suggested cutoff. Okay, so here it is. So here are some suggested values. So what BURI does is it passes those values and shows them here, and it picks them up automatically. So if you just go ahead and select this pseudo potential by double clicking on it, then it will automatically reflect those changes right here. However, the another great part is you can even download the pseudo potentials from the Quantum Espresso website. So it will open a browser in the software itself, and it will load up the Quantum Espresso pseudo potentials web page. So from here you can go ahead and download any new pseudo potentials that you want, or if you prefer something else. So that is the elements tab. So it shows, basically it is used to pick up a pseudo potential of your choice. All right, and then we have the atoms tab. So this is basically useful for specifying the atomic positions. So you can specify the units in which you are going to be specifying your atomic positions, and then just edit these values right here. And then whatever you changes make here will get reflected into the input file. So we change the pseudopotential, therefore we have these changes here. So I'm gonna go back and just switch back to an ultra soft pseudopotential. I guess this one. All right, so that was your geometry tab. So this tutorial is about modeling and stuff, so therefore it was necessary to cover all this. And let me just switch it back to cubic lattice, because that was messing up with the visualization a bit. So okay, so now you can see that this atom is being shown as selected. That is because I selected it right here. So if you click on this one, then it will select all these 4 atoms, because I'm sorry, 8 atoms, because they correspond to a single atom, because each atom is being shaded by 8 cubes. And so just you can unselect these by I don't know, like right clicking on this and not select any atoms or what. Okay, I'm not sure how do I unselect it. Okay, and even you can add atoms to it. However, I'm struggling a bit here to unselect this. However, that is not a big issue. So just go back and by the way, since we are talking about modeling, so in case you have to perform something like doping or create an impurity, so let's say you wanted to create a vacancy in the center of this Fe lattice, so you can just go ahead and right click on it and delete this atom. So there you go, now you have only one atom in this lattice. However, you can just press Ctrl Z. Okay, it's not working, so you can just go ahead and load it back if you remember the coordinates. However, I did not note them down, so let me just go ahead and open this file again. Close it so that it doesn't save any changes, and then open it back again. So coming to the modeling part, so we can we can delete a single atom to create a vacancy, and we can even perform doping. So if you want to perform a doping, then you can just replace this by double clicking here and then writing any other atom symbol like gallium. So here we have replaced this atom by gallium. So that is how you perform doping and vacancies in BURAI. So that is the method to do that, and that's that's how you do it. And you can, another way to be doing this would be to change it from here. So here also I can perform these changes in the input file, like I can change it to germanium and then click this button right here, so that the changes will reflect onto the this visualizer. So now I have replaced it with gallium, and again I can do another change here by making it silicon. I'm sorry. Okay, and then just clicking right here to reflect these changes here. So that is how you create an impurity, or doping, how you perform doping, or you create a vacancy and all that stuff. Now there are a few more things that you can do modeling wise. So here you have a designer here in Quantum Espresso that can be used to display your system in various models, like a ball stick model, ball model, or is simply a stick model. So I prefer the ball stick model. And then you can even change the colors of the background to whatever you want. So that is great. Again, then you can change the font colors here, denoting these different atoms. You can choose to whether you want to show the legend or not. You can choose whether you want to show this axis or not, and then you can even choose the color for these particular atoms. So you can click on whatever atom you want to change, and then you can specify a color for it, and you can even change the radii, etc., bond lengths, or I mean bond widths, all that modeling stuff. Like you can make these bonds thicker. So that's something that you want to do, then you can do it. Then you can choose to whether you want to display the cell or not, and you can even choose the color for the cell lines that you are seeing. And then again you have the option to change the width of these cell lines, and that's it, I guess. So currently I don't have any affiliate atoms in my lattice because I switched them with silicon and germanium. So I should select germanium and then change this color to anyone that I want, to red maybe, and then change the color of silicon to something like green or blue. So that is the another thing that you can perform using the designer of this um, BURAI software. So this video is getting pretty long, so I should probably end it here. However, there are a few more things that you can perform using BURAI in case of modeling. So here when you click here, you have a modeling tab, and there are modeler tab. So there are a variety of functions that you can perform using this. However, I'll be covering these in the next tutorial because this tutorial is getting rather long. So that's it. Thanks for watching, and if you guys enjoy this video, then don't forget to hit the like button and subscribe to my channel for more videos like this. And thanks for watching, and have a great day.